You're listening to Word on the Reef, diving into marine science on the Great Barrier Reef and beyond, with Tanya Murphy and Brett Goodban. Good morning, everyone, and welcome to Word on the Reef. I'm your host, diver and marine conservationist Tanya Murphy. And with me, as always, is Cairns Aquarium's marine educator and fish whisperer, Brett Goodban.
Good morning. Geez, we're excited for this one.
Yeah, but before we dive into today's topic, a quick news update. Scientists from Hokkaido University in Japan have uncovered the fossilized jaws of an ancient octopus, estimated to have reached an astonishing 19 metres in length.
Say what?
Dating back to the late Cretaceous period around 100 million years ago, this creature's powerful jaws may have been capable of crushing the bones of ancient sharks and marine reptiles.
Crikey.
Terrifying, but also very cool. It certainly challenges the idea that mollusks have always sat near the bottom of the food chain. At times, it seems they were very much on the top. I'm never going to look at an octopus the same way again.
So probably the only thing that would have kept me out of the ocean is one of them, a 19-metre octopus. Definitely.
It actually reminds me of a really terrible B-grade film I watched once. I can't believe it exists, but it was called Mega Shark versus Giant Octopus.
Oh, like Sharknado. Yeah,
but worse. The premise was that melting polar ice released prehistoric monsters back into the ocean.
Wow.
Not saying it was scientifically accurate, but hey, one more reason to take climate change action.
Yeah.
Anyway, on to today's topic.
Yes.
Today, Brett, we're heading to Lady Elliot Island at the southern tip of the Great Barrier Reef in the sea country of the Bailey, Gureng, Gurung and Taribalang Bunda peoples. To get there, we'll hop on a small, low-flying aircraft for a 30-minute flight from Bundaberg. I have actually done this trip myself, and in winter you can sometimes spot whales from the plane.
Yes. Well, the wild migration's just started early already.
Has it?
Yeah, they've seen humpies already. The girls are coming.
Perfect.
Yep.
As the island comes into view, we can see it's a low-lying coral cay just 2 kilometres around, with a resort, a lighthouse, an airstrip, a fringe of white sand, and a brilliant turquoise reef. Suddenly, people start shouting and pointing out the window. A huge conga line of manta-rays is circling the island. Manta-rays get their name from the Spanish word for blanket or cloak, and that's exactly what they look like. Giant, graceful, swimming blankets. There are 2 species, with oceanic mantas growing up to 7 metres across and the reef mantas up to 5 metres across and weighing over a tonne. Despite their size, they have no sting and are completely harmless. They feed on plankton, up to about 27 kilograms a day, scooping it into their mouth using cephalic lobes, the flaps on either sides of their head. When these are rolled up, they look like horns, which is how they earned their other nickname, the devil ray. Now, at this point in our story, everyone's desperate to jump in the water, but we'll have to wait until the seatbelt sign is off.
Yes.
Once we land, one of the first things we notice is the sound of tens of thousands of nesting seabirds. Lady Elliot Island has one of the highest seabird diversity levels on the reef, and birds are nesting on every branch of every tree. Hermit crabs are scuttling underfoot. It's an explosion of life both above and below the water. Sadly, in 1863, settlers stripped the island of its native vegetation and mined it for guano, bird droppings used as fertiliser. But in 1969, an eco-resort was established and extensive revegetation began. Today, the island runs largely on solar power, produces its own drinking water through desalination, composts all its food waste, and offsets flight emissions. And just to be clear, this isn't sponsored. I just really, really love the place.
Yeah, that's right. Yeah, it's a pretty special part of the world.
So to continue on our imaginary holiday, we've barely dropped our bags before racing straight into the water, and we're not disappointed. Dozens of manta-rays glide and loop around us. Curious, graceful, and completely unafraid. This aggregation lasts for weeks each winter, and add to that the vibrant coral, abundant marine life, and the constant soundtrack of whales singing. It's absolutely unforgettable.
Yeah, heaven.
So, yes, everyone, if I've just convinced you to spend your life savings on a trip to Lady Elliot Island, you're welcome.
Off you go.
But what exactly brings these manta rays here each winter? Where do they go when they leave? Do they have intelligence and individual personalities? Can humans form connections with them? How many are there, and what threats do they face? To take us deeper into the world of manta rays, we're joined today by Kathy Townsend, Professor of Marine Biology at the University of the Sunshine Coast and lead researcher with Project Manta. Good morning, Professor Townsend. Welcome to Word on the Reef.
Good morning. Thank you for having me.
Morning, Professor. We're so excited for this one.
It's great to have you on the show.
Yeah.
Now, you've probably spent a lot more time on Lady Elliot Island than I have. How did I go with describing it? Did I miss anything?
No, you did really well, actually. Yeah, I've been very fortunate to be going there pretty much at least once to twice a year since about 89. So it feels like a second home, and you did a very good job describing it.
Thank you. I'm so jealous that you get to go there so often.
I'm a bit jelly too.
Before we dive deeper into Lady Elliot Island and its manta rays, can you tell us a bit about yourself and your background and how you came to be passionate about the ocean?
Yeah, so you can probably tell from my accent that I didn't grow up in Australia. I grew up in Canada in a place called Calgary, which is just on the east side of the Rocky Mountains. And it doesn't seem like that would be a place that would grow a marine biologist very organically. But at the time, Jacques Cousteau documentaries were on the telly. And to me, that was the most magnificent ecosystem you could possibly ever imagine discovering, because when I was little, the moon landing had happened and people were really excited about being an astronaut. But if you become an astronaut, the kit's really cool, you get to go on rockets and stuff like that, but when you get out, it's basically just looking at rocks, right?
To our knowledge, there's not that many animals out there.
There's not much out there. So to me, underwater was even, particularly back then, was not really very well explored. And it was way cooler than space because there's things living under there that our imaginations couldn't even come up with. Like, they just look like crazy things. So that really, and of course I really loved water as well. I was always swimming all the time. And I was one of those kids that was like, as soon as I could get my dive certificate, that was it. That's what I did. And I learned how to dive in Canada in a freshwater lake. My first open water dive was an altitude dive in a freshwater lake that had just defrosted.
Oh my goodness.
It was snowing on the day.
Brett's shivering.
I'm out. That's it.
And it was back in the days when we didn't, it was only like the SAS who had access to dry suits. So it was an 8mm wetsuit. And I remember going down, as you're going down, I looked over at my dive instructor, who was an ex-SAS diver. He had this white beard. His face was the same color as his beard, and his lips were bright blue. And I was thinking, what am I doing?
I'm just going to stay on the boat if that's okay.
That's the definition of, there wasn't a boat. They were in the Rocky Mountains.
You lug all your dive gear up there.
Yeah, so it was a shore dive as well. So it was pretty exciting. We really,
that's dedication.
You'd see one brown fish and you'd be excited for weeks. And so hence, when I came out backpacking to Australia and went diving on the Great Barrier Reef, that was it. I was hooked. Even though, at the age of 6, I said I wanted to be a marine biologist, but everybody else wanted to be a fireman or whatever. And I finally got out to Australia backpacking and did my first dive on the Great Barrier Reef, and that was it. I was hooked. And my poor dive buddy, who was from Australia, my eyes were as big as saucers, and I was literally pointing out every single fish. And he's like, yeah, I know. But that was it. That's when I completely and utterly fell in love and said, this is the place I need to live and work.
I love that. Let's talk about Lady Elliot Island now. And before we dive beneath the waves, what can you tell us about the biodiversity of the island as a whole and the interconnection between the plants on the island with the marine ecosystem beneath the waves? Because I understand you have a whole project revolving around that.
Yeah, so we have another project called Leaf to Reef, which is looking at the connectivity of what happens on the island to what is actually happening on the reef. And this is really looking at that nutrient trail. So the coral K that makes up Lady Elliot Island is basically just a barren, like if you remove the vegetation, is just barren calcium carbonate base, which is really difficult for plants to be able to grow in because there's not a lot of nutrients. It's quite dry. But what's really allowed the plants to flourish there is the birds. If there was not any birds, there would not be any plants on Lady Elliot Island because the birds bring the seeds, but they also bring the nutrients that allow the plants to be able to survive. And there's this real close connection because the birds are obviously going out and fishing, digesting the fish, coming back to the island, pooping, providing that guano, providing that nutrients, which then allows the trees to grow. But not all of that nutrient gets sucked up by the tree. Some of it ends up actually washing its way back out onto the reef itself. And the work that we've been doing with Leaf to Reef has shown us that that nutrient is really important for maintaining the ecosystem around Lady Elliot. And it's all literally interconnected. So if you have a big die-off of birds during one particular season, it actually will interfere and interact with that nutrient.
It's just such a well-balanced environment, isn't it?
I imagine it must be quite a localised effect because so many reefs out there don't have an island covered in birds to do that. So only the reef around Lady Elliot Island has adapted to rely on or be adjusted to those bird droppings, I suppose.
Yeah, so it really just does depend upon the island itself, right? So some of them are just barren sand mounds, basically. But when you've got these fully developed islands where you've got lots of birds, that nutrient cycle is very much connected.
Wow.
And the other real important thing about Lady Elliot is that, I'm sort of sneaking off on a side quest here, but Lady Elliot, one of the reasons we're really interested in its biodiversity, for example, because the island itself is amazing biodiversity as far as birds are concerned, but then we also have this incredible biodiversity of marine species that live around the island as well. And what we think in some modeling that we've been doing, it appears that unlike lots of other places in the Great Barrier Reef, because it's the very southern reef of the Great Barrier Reef, we're predicting that the biodiversity of that reef is either going to at least stay stable or actually go up, because what it's going to do is catch all of those climate refugees that are moving from those hotter equator areas, and we'll be catching them on our reef itself. So one of the big projects that we did around Leaf to Reef was we had to come up with a list of who we got here so that we could try to see this change over time. And so from that, we ended up creating the field guide to Lady Elliot Island, Great Barrier Reef, which is going to be launched in about 3 weeks' time.
Nice.
And that's got over 800 species, including a couple new species of fish that are new to science that we discovered through this whole process of just trying to get a handle on the biodiversity that is Lady Elliot. And that's just the vertebrates. We didn't go into the corals and stuff. That would have taken us. It took us 6 years just for the vertebrates. It would have taken us longer otherwise.
Yeah, and so you've got photos of all these animals. Yeah, it must have been a big project to document them all. But yeah, it's really important, like you said, to get that baseline so that we can see if there are any changes, if there are any sort of new species that are coming down from the north and moving there. That'll be really interesting to compare over time, I guess. So congratulations on the book.
Yeah, well done.
Thank you.
So exciting.
We'll put a link in the show notes in case anyone wants to get the field guide. Now,
wonderful.
Yeah, let's talk about the manta rays now.
Oh, yes.
Of course, yes.
Professor Townsend, do you have a particular memory about the first time you fell in love with manta rays? Because I can guess it wasn't in the lake in Calgary.
No, it was not.
What was it that made you fall in love with them?
Manta rays it's such a wonderful experience to dive with them because they're very curious. I've had manta rays. I think this is probably the time where it just finally said, this is the animal I'm working with forever. I've had animals come so close. They'll look at you eye to eye. And I've had one come so close that it's basically brushed over my head and the tail draped across my shoulder. It went past. And if you have that kind of experience, I mean, you'll know this, Brett, like marine animals generally just don't pay any attention to you. Manta rays will change you, and we've got heaps of footage of this. They'll actively change their direction. They'll see you. They'll come and change their direction and literally come and check you out.
Well, I have a very similar story to that. my first encounter with a manta-ray was when I was filming up at the North Horn, up in the Coral Sea.
Yep.
And I just descended over this bommy, and I noticed a whole heap of cleaner acid, and I was filming some other stuff, and I looked up and I saw this massive manta come towards me. So I just held my ground and I thought, right, this is going to be amazing footage. I'll just see what he does. And he was doing circuits over the cleaner ass, and I was just watching him. And I don't have any hair. I have a shaved head. And anyone that knows you got a shaved head, if you don't shave it for 3 days, you end up with what's called Velcro head, right? So this guy decided, he came over and he got a little bit too low, and he's brushed his belly across my head. So he went from the front to the back, and he did this big shimmy. And I thought, oh, he's gone. He wasn't gone. No, he did it 4 more times. He went round again, and every time he got lower and lower, and I had this 5.5 metre manta-ray brushing his belly on my bald head all by myself. And I thought, do you know what? I have the best job in the world. It was just so awesome. And that's what they do. They're just such a magnificent animal.
It reminds me of a cat just coming and brushing up against you.
Oh, he was, the cleaner ass weren't happy because I was taking the attention away from them, and they weren't making any money. You know what I mean? Excuse me. We've got a booking. Move on. Yeah, very special.
Well, we used to collect, so one of the ways we try to get genetic samples, and I'd actually have a toothbrush on the end of basically, one of those pointing poles that you use when you're dive mastering. And you would go up and you would basically scrub the back of the manta. And the first time we went to go and try it, I thought, oh, no way. It's just going to, the mantas is just going to take off.
Yeah.
No, they come back exactly like your Velcro.
He absolutely loved it.
They wanted some more of your dental treatment.
Yeah, I wanted to keep going back every year to see if he was going to come in for another scratch. Yeah.
Now I want to wear a brush on my head when I go down.
Well, you're welcome. You're welcome. This has just opened up a whole new level of research for you.
Wow.
Exactly.
Wow. So they love a scratch, but of course, I don't want to encourage anyone to...
Yeah,
please don't go out and scratch.
Don't touch them. Please don't do that.
No. It was all on his terms, I'd like to point out. It was all on his terms.
Exactly.
Yep.
Exactly. Because normally they would take off if you even tried to touch them. So,
So it's not just Lady Elliot Island. You've travelled all around the world researching mantas. What have been some of your best ever manta ray experiences around the world? Because we both watched your documentary about Project Manta, and there was a couple of places in there that blew our minds.
You're probably referring to the Maldives.
That was it.
Yeah. So the Maldives is this incredible spot, and we're still doing research out there. I've had 2 PhD students work out there so far. Hanifaro Bay is this relatively small area that is about the size of 2 football fields, so it's not huge, and it's relatively shallow. It's only about 20 meters at its deepest part. But certain times of the year, the wind and the currents just work the right way so that this massive upwelling of nutrient-rich water filled with plankton ends up inside this bay. And what it does is it attracts every manta from around the area. So normally mantas are fairly solitary. They don't normally hang out in big groups unless the food is on. And in this particular location, we were very fortunate. We were there during the peak season. It only happens for about 2 weeks a year where all the, everything lines up. And when we were there, we had over 250 manta rays in this area, plus 2 whale sharks. That's
the bit of that I actually cracked up when I saw that. It was like that meme, you think you're the coolest guy in the parking lot, and the whale shark just turns up and goes, "Look out, you lot, coming through." The giant vacuum cleaner, and the mantas are like, "Oh, here comes Wayne." Every time.
I was almost in tears because I felt like I was there, I was imagining it, and I was like...
just wanting to be in there with them so much.
It was so fun filming there. And the thing is that to me, it was almost overwhelming because usually when I'm in the water with mantas, I'm trying to get a photograph of their underbelly because we can identify individuals with those dot and spot patterns. And so I felt like I was in Times Square trying to photograph every single person that was going past. You know what I mean?
Yeah.
It was just so overwhelming.
Like a kid in the candy store. You just don't know where to look next.
Yeah. And I was snorkeling on the surface doing this. Yeah. And then all of a sudden, this whale shark comes up from underneath my belly.
Wow.
And I'm like, oh my God, like there's a whale shark straight underneath me. And, you know, you're lying flat, snorkeling.
Yep.
And then all of a sudden, the dorsal fin went between my legs. And I got goosed.
Oh, my goodness.
Wow. Crikey.
You would have discovered how fast you could swim.
I don't know if many people have that on their resume, just quietly.
No, goosed by a whale shark.
Wow.
Yeah, it was quite funny, but absolutely spectacular. And some of the behavior that goes on there, because the plankton is so thick there, the mantas undergo a range of behaviors that you don't see in other locations. So normally when a manta is feeding on the surface, they're basically quite close to the surface. Their mouths are wide open. Their cephalic lobes, which are those pointy bits at the front, kind of moved into sort of more of a funnel shape, which is funneling all the water into their mouths. And that's usually, and they're just sort of skimming just underneath the surface. And that's standard sort of feeding you would expect to see. But at the Maldives, it's completely different. They do all these different kinds of behaviors. They do what we call this stacking behavior, where there's basically one manta stacked about half a body length behind the other.
The flying V formation.
Yeah.
Well, not so much of a flying V formation, but stacked like a staircase. So one on top of the other.
Wow, they're really doing a grid pattern so they don't miss any plankton. They're going to hoover up every last bit of it.
Jeez, the old
And that's
plankton.
what they're doing. So as they hit the only defense that plankton has is to potentially jump out of the way to prevent being eaten. And
So
they
it goes
often
up.
jump up.
Yep.
And so what you do is if you've got a stack, you make sure that everybody's making sure
That is so cool.
they require. Yeah. And then, of course, the most spectacular is the cyclonic feeding.
Oh, that was incredible.
And it's the only evidence of ray doing cooperative feeding where the animals all swim. They all start to swim in the same direction near near sort of against a wall near the end of the bay. And as they are swimming together, they're big, but we're talking animals that are 4 meters, you know, wingtip to wingtip.
Yeah.
They're massive animals, all swimming together, and they create a vortex. And it starts sucking all of the plankton into the center. And I was diving. I had an opportunity to see this both diving and snorkeling. When you're diving, you can feel yourself being sucked in towards the middle. But when you're snorkeling, you feel it being pushed back out because, of course, it comes up and then back out again.
That's just...
And then every once in a while, one of the mantas in this vortex will break rank and they'll go through the center and get this super concentrated mouthful of food. And then join back in the...
So they take it in turns, though they do the work, and then one goes in and gets the spoils, and then the next one will do it after that. So they're all working together to get that big mouthful.
I wonder
incredible.
How they remember whose turn it is. It's incredible.
I don't know. I don't know if it's...
Probably pick a name out of the hat. All right, Frank, you're first today, mate.
It's your turn now.
Yeah.
But the thought of these hundreds of manta rays swimming in a big spiral in a raynado, so to speak, and actually sucking all of the food into it like a big old food processor. It's a plankton smoothie. It's just amazing.
Yeah, and we've discovered that those behaviors are very much linked to the density of the plankton in the water at the time. So those behaviors will not kick in until a certain amount of plankton is available. And even just normal feeding, it won't kick in until there's a certain level of plankton in the water to make it worth their while. Because it's energetically really costly to basically swim into the current with your mouth wide open, you know, collecting all that plankton. If you've ever tried to drag a bucket through water, you know, it takes a lot of energy. So they're not going to do that unless the rewards are going to be there.
Right, and so in the documentary that we watched, you were sieving the water to see what kinds of plankton they were eating, and I think you found that it's the similar types of zooplankton both in the Maldives and in Australia that they tend to favour the most, the tiny shrimp-like planktons.
Yeah, so it's these copepods. They're called copepods, and they're related to shrimp, but they never get as big as a shrimp. That's as big as they get. But yeah, it's very similar food source that they're going for, and we still don't really know how they know when masses of these animals are going to show up in one particular place or another, because You can imagine the ocean is very, very big. They do roam around a lot trying to find their food sources. We know that they make decisions as to when they're going to start feeding. How do they make that decision?
Yeah,
you can't see plankton as such. They certainly have electrosensors all over their body. But this is my running hypothesis, is that instead of using those electrosensors for detecting fish if there were a shark, they're using it instead to feel, because we can even feel it, to feel the plankton bouncing off their skin or close to them, to be able to get a sense of what the density of that plankton is.
Professor Townsend, another place that I'm very interested in with regards to its manta rays is a tiny island in Micronesia called Yap, where the mantas are so revered that their whole habitat is protected. And I know that you've been there. What can you tell us about the manta rays of Yap?
The manta rays of Yap are incredible. First of all, it's a really important site because it was one of 2 locations around the world where really enthusiastic naturalists started paying attention to the spot and dot patterns on the animals and thought, maybe we can use this to identify individuals from one another. And so Bill, who was the gentleman that I connected up with and had been working there for, by that stage, he'd been working with mantas for almost 25 years. He was really one of the pioneers of this technique. And he had this amazing database of individuals that he could tell who they were. And one of the ones that was most special to him was a little female that he knew from when she first arrived. So she was very small. She would have been 1.2 meters wingtip to wingtip, so had just been born. And her name it's Valerina. And Valerina was named after his daughter when she was very, very young. And now Valerina's would be 30 plus years old now. So it was such an important location for that reason, because as I said, it was sort of the pioneering of using natural patterns instead of having to put a tag on something, right? So it's completely non-invasive. It means that these animals, you can just observe them without hurting them. And it also means you can then bring citizen scientists in with people with cameras. You can get a photo. It contributes to science. And the other reason that Yap is really cool, well, first of all, the environment there is incredible. You've got mangroves that go right to crystal clear reefs.
Wow.
And these really deep channels that run between where the reefs are and where the mangroves are.
More places for the bucket list.
Oh, God.
Exactly.
One Powerball.
Yeah, and if you do go during Yap Festival, because the culture there is still intact, and it's just an absolutely amazing event. And like you said in the introduction, manta rays are very much part of the culture. They're very revered animals, and hence why their habitat has been fully protected as well.
What do we know about the reproduction habits of manta rays?
Yeah, so mantas are a little bit like elephants and whales in that they only have, first of all, they have live young, but then they only have one young every 2 years. That's the fastest that they can have it, is one every 2 years. Sometimes it's longer than that. The females are pregnant for anywhere between 12 to 13 months, again, very similar to whales and elephants. And when they do give birth, it's one single individual, and they come rolled up like a sushi roll.
Oh, yeah, little burritos.
Yeah, little burritos, and then they unfurl, and they're 1.2 meters from wingtip to wingtip, and it's basically fully formed and ready to go.
Wow.
And so the maternal care happens in those really long gestation rates. But then as soon as it's born, basically, it's off on its own after that.
Wow. That's so cool. Is that oviparous?
Yes, oviparous.
Look at me, I know my stuff.
So that means no eggs, live birth?
No eggs, it's
That's
live
right.
birth. It's oviparous, not oviparous.
So they're all just ready to go.
They're all ready to go. And, absolutely beautiful little creatures.
Have you seen one being born? Do you know where they all go to have their pups?
No. So this is one of the biggest mysteries, right? You know this with the elasmobranchs. They often get together and we'll have like a nursery area where the young all hang out. We don't really know where the nursery areas are in the world. It does appear that maybe Yap might be one, because they do see very young ones up in the mangroves, but that's one of the very few places in the world.
Oh, maybe they hide in the mangroves to have them or something.
Well, we
theoretically.
don't know, like whether they could go up really shallow, like someplace into the mangroves, but we would expect more people would see that. The other option is they go deep. They go out deep. So the mothers are going to try to give birth someplace where they're not going to be attracting predators. So to try to give their young the best chance of start. But we're not really sure. That's one of the things we're trying to discover here in Australia. We see pregnant females all the time. Where are they going to give birth? Where are the young? Maybe they're doing big migrations. Well, we know that we see really small ones up in Indonesia. Maybe our big mamas are migrating up to Indonesia, giving birth, and then coming back down again.
So
we don't know.
Similar to baby sea turtles, isn't it? When they hatch, we call it the lost years. We don't know where they go when they hatch. They just disappear, and then mum turns up to lay eggs.
Exactly.
Yeah.
They're still outsmarting us.
They are.
I love that.
They are still outsmarting us, exactly.
And speaking of that, how intelligent are manta rays?
Manta rays have this countercurrent system that actually keeps their brains warmer than the surrounding environment. Most sharks and rays, and fish, are basically a slave to whatever the water temperature they're in. They're exotherms, so they basically are just as whatever the water temperature is, that's what their body temperature has to be at. Now, manta rays, they actually have this countercurrent system that creates a warm network around their brain, which means that they can have greater neural functions in a greater range of temperatures. And you can kind of see that in the quite complex behaviors that they undergo, the fact that they do things like cooperative feeding, which not a lot of other sharks or rays will do that. And of course, just they will actually interact. Like you can, as I said, you can actually see them sort of clocking you. They're recognizing that you're something foreign in the environment, and they'll come over and kind of check you out. And they're also very expressive, too. So those cephalic lobes, we actually did some behavior work looking at how do manta rays communicate with one another, how do they potentially communicate with other species. And those cephalic lobes at the front are very, very expressive. If you're in the water with a manta ray and its cephalic lobes are nice and loose and sort of floppy, you know that animal's nice and relaxed. And you often see that kind of behavior when they're circling around the cleaning station.
Oh, it's like a dog's tail.
Yeah, it's just like that. But if you come up to them, say from the side, and they're a little bit unsure about what you're doing, you'll see that the cephalic lobe that's closest to you will start to furl. It'll start to curl to what we would normally call when they're basically about to fly, like their flight response. So you can see as a diver how you're impacting that animal by your own behavior. So if you see that and you back off, like you get down a little bit further, they want you down beneath them because they can't see above. So if you are interacting with a manta ray and you're diving, get down low, kneel on the ground. Don't kneel on coral, obviously, but kneel on the sand. And the manta will come to you and check you out. But if you really annoy the manta, what will then happen if you see both of those cephalic lobes curling, that's their flight response. And that means that they're about to take off.
Right.
So again, even with those sorts of things, you can sense communication. And they communicate to one another using that same cephalic lobe kind of code as well. So, it's very hard to quantify intelligence for a species that's not our own. It's even hard to quantify it for our own species.
Yeah, it's hard enough for us.
I mean, it varies greatly within the species.
It does. Yeah.
So, but, they're very good at what they're doing. They have this capacity to have much greater neural functions than other animals that are sort of in their same grouping.
Yeah.
And we do see these quite complex behaviors. So are they intelligent? I think they're very intelligent for what they need to be doing. So,
something that really caught my eye, which I thought was fascinating, was they still have the little lump on the back of their tail where the barb used to be.
On the oceanics.
On the oceanics.
Yeah, whereas the reefs, they've completely lost it.
Yeah,
they don't even
it's incredible, isn't it?
Anymore. So that shows you how they have evolved from a standard ray, right?
Yeah.
So they would have had a barb at one stage, but with the reef manta ray, it's completely lost. But with the oceanic, it's basically like a calcium carbonate lump that sits over top of the actual spine itself, and it just sits under the skin. So it's non-functional.
It's like a vestigial tailbone in a human.
Yeah, that's right.
Exactly.
Yeah, and it's important for our listeners out there that are listening to this, that are just drifting off into heaven, listening to us talk about these, that, mantas do not have a stingray barb. They don't have those. So
the only thing that could possibly happen is you could get slapped. And if you did, you probably
like the turtle did to one in that little meme a while ago. The manta came too close to the turtle and gave him a backhand.
Manta slapped.
Yeah.
Like getting hit across the face with a wet crate.
Yeah, I'm glad I never experienced that.
So with the intelligence, is it possible that a person can actually befriend a manta ray and that the manta ray will recognise them? Because I saw a bit of that with Bill from Yap with his favourite manta ray, Valerie. She can recognise him out of a group of divers. She'll go up to him, won't she?
Yeah, definitely. And, I mean, I took some takeaways from Bill, having spent time with him as well. I always wear very similar sort of headgear every time I go in the water. I always do a similar sort of sign to the animals every time I see them. I give them a wink, blow a kiss, and give them a peace sign. And I think definitely with Bill and Ballerina that they definitely had a connection between the two of them. But he's been diving with her almost every day for 20 plus years, and obviously he never did anything to scare her or make her concerned. So, she's gone,
that's we've all had those special connections with animals underwater. It's just, it's something that's, it's an honour when you're down there in their world.
That is exactly right. It is an absolute honour to be
accepted into their little world, They don't know who we are. We're just this foreign object.
We're aliens.
Yeah, that's right.
Yeah.
When I was watching your documentary, Professor Townsend, I think because we talk about so many different marine animals and I've seen so many, I'm always flipping and flopping between which one's my favourite. It changes every day. But right now, it's definitely manta rays. I'm like, these are the best. They are the best animals on the planet. Now,
I completely agree.
How fast can they actually swim?
That is a really good question. We have not been able to put an accelerometer tag on them yet. So we need...
Just point one of those roadside
we'll just borrow one of those radar things from the coppers and we'll just sit there and record one.
Excuse me, sir, you've exceeded the limit.
Yes, pull over.
Yeah, exactly. The only problem is they don't work too well under the water, so that's the problem. But, we've tried a couple of times to put accelerometer tags on them, which... When we put tags on the mantas, we never restrain them. So unlike putting tags on sharks, for example, they'll often fish for the shark, bring the shark up alongside the boat. Sometimes they'll even bring it onto the boat, and they'll pump water through the gills so the animal's still breathing, and then they can clamp and screw a satellite tag onto the actual dorsal fin of the animal so it's nice and stable. And with an accelerometer tag, you're getting not just X and Y values, you're actually getting Z values as well, so you get all sort of space in 3 dimensions. But for manta rays, because we actively don't catch them, it's become quite problematic on figuring out how to try to put one of these accelerometer tags, particularly on their tiny little dorsal fins. They do have a dorsal fin, it's just tiny. And I had one student and the developer of the tag madly trying to clamp these accelerometer tags onto these tiny little dorsal fins, and the mantas would just shed them off almost immediately. So I cannot answer that question of how fast they swim simply because we have not had the ability to put a speedometer, to put it into layman's terms, on a manta ray yet. But we do know it's very fast. Because they have no teeth, they have no stinging barb, the way that they protect themselves is through pure speed.
I did see that the oceanic manta, which is the bigger one was found travelling something like 2,000 kilometres or something. I can't remember the exact distance, but in quite a short space of time, which made it faster than a whale migration.
Yes, on the long distance, definitely they can haul pretty quickly. But they're so efficient in their swimming as well. When you're in the water with them, you're panting, to snorkel to keep up with them. And they just do a little flick and they're gone, like tiniest little flick of the end of their fins and they're gone. They are made for speed.
So much greased so lightning.
Yeah, exactly. But so much so that the stealth bomber from the United States, which is a ray-shaped fighting plane, was actually based upon the form of manta rays. So they looked at how manta rays move through the water, and then they basically took those lessons to the stealth bomber, which, of course, is designed to not make a lot of noise, to be really aero efficient, so being able to move through the air without disturbing the air, and which, of course, is the thing that causes the noise. And they learned all their lessons by studying manta rays' shape and manta ray skin with their little tiny dermals all over their skin, which helped to, like the dimples of a golf ball, help to break up some of that wind as it's moving over the surface of the animal.
So what is Project Manta? When did it start and how and why did it come about?
So Project Manta is basically a nationwide project looking at manta ray biology and ecology around Australia. Very much started at Lady Elliot Island Reef as well as North Stradbroke Island. The reason we started this, I was actually invited back in 2003 by a dive group on Straddie who was having a manta fest, and they said, would you be willing to give us a presentation about manta rays? And I said, yeah, sure, not a problem. And I thought it would be not an issue because I'd just look up the latest literature and give them a really nice talk. And then it turned out that there was 5 publications on manta rays in all of Australia. 3 of them were taxonomy papers, and the other 2 were just because they happened to see manta rays when they were doing surveys for other animals, and they mentioned them.
Oh, an afterthought.
So basically we knew nothing about them.
So we knew nothing. And back then, we thought all mantas were manta birostris as well. So we all thought that they were just the ocean-going manta. So this is really what spurred me on because, like you said, every ocean-based documentary has manta rays in it, and yet we knew nothing about these animals. I thought, this is insane. And so that's how it all started. And I knew that there was manta rays at North Stradbroke Island. I also knew there was manta rays up at Lady Elliot Island. And so my very first question was, are they the same group of individuals moving back and forth? Or are they 2 different populations that are completely separate? And that was literally the very first question that we asked. And that's where we started doing the photo identification, reaching out to the dive community to get photographs of the bellies of those animals so that we could get an idea of where they might be moving. And then as we started to get money and gain momentum, we were able to put satellite tracking tags on the animals as well as acoustic tags as well. And there's a big acoustic array system that picks up animals as they go past. So through that, we found out pretty quickly it is the same population moving back and forth between the 2 areas. And one of the things that we have found out is that we currently have the world record holders for manta rays distance. So most of the reef mantas only go about 300 to 400 kilometers between locations and other places in the world. Our animals regularly go over 500 Ks.
Wow. But
we also have a couple of individuals that actually have gone as far as from North Stradbroke Island all the way up to Cairns, which is well over 1,000 kilometers.
Wow, the tourist or diver who snapped that photo and then found out it's come all the way from Straddie, that must have been so exciting.
Yeah.
It was exciting for us because at one stage we thought there was a real barrier because we were getting animals sort of above Townsville and we were getting animals below Townsville, and we weren't seeing a lot of mix between those 2 areas. And it wasn't until we started getting more photos from up north that we were like, oh, no, they are actually doing that entire distance of that coastline.
So it's a one East Coast population.
Yeah. And we've done genetics on that as well. So there's one single East Coast population, which is different from the West Coast population, completely separate. The West Coast population...
Same with the whales.
Yeah, same with the whales, same with the turtles, same with the sharks. Like, it's pretty common in the marine world that's what ends up happening.
So you've got diagrams of hundreds of manta rays that have been identified. Do you think AI will soon be able to make your job faster? You must spend a lot of time analysing all the photos that get sent in.
Yeah, well, we actually have quite a good system, because what we've done is those dot and spot patterns, we've given them names. And so we've got these series of folders where we can say, okay, is it male or female? Is it black or white? Because they come in two different color morphs. They come in either the black morph or the white morph. Does it have any shark bites or missing a tail? And then how many spots does it have, between its gill? And then we can put more and more of these identifiers on the individuals. And then instead of 1,500 photographs or 1,500 individuals, we're now down to maybe, in a bad day, 10, but maybe as small as 5. Yeah, and then we just visually compare and go, oh yeah, it is this one. The only time is when we can't see it, we then have to physically flip through the entire catalog to cross-check just to make sure that animal hasn't been spotted previously.
Wow.
It's a big job. How many manta rays have you identified?
So we currently have around 1,375, I think, but then similar sort of numbers on the West Coast as well, and we're constantly cross-validating with what's happening at the West Coast as well. So there's around over 3,000 individual manta rays that have been identified in Australia to date, and they're still going. The population here seems really healthy, keeps growing. We keep seeing the same individuals time and time again. Like there's one animal, his name's Taurus. He's our oldest known manta ray. Again, this is because of citizen science who've been able to give us an idea about this. He was photographed back on Lady Elliot Island back in the 80s, the early 80s.
Wow.
He still comes every year.
So he's 40 plus, yeah.
Yeah. Well, he was already sexually mature then, so he would have been 10 then, so he's over 50 now.
Oh, he's an old boy, and probably they can get a lot older.
50's not old, thank you very much. He's a whippersnapper.
He's still mating, he's still on
He's still going, yeah, good on him.
He's still
there
going, yeah. So it's pretty exciting being able to get all of this information about the animals, what they're doing, how long they've been hanging around. And again, just a lot of this is coming from citizen scientists, people providing these photographs for us, going back, finding that old shoebox under their bed where they went to Lady Elliot in the 1980s for their honeymoon, and going, oh yeah, I did get a photograph of the belly of a manta. I'll send that in. And then turns out that it's one what we're still seeing today, which is absolutely incredible.
That's awesome.
Could be the missing link. Everyone, check your photos.
Yes, check your shoeboxes.
Photos. We want them.
Any photos of manta rays anywhere in Australia, actually, for your project.
Yes.
What brings the manta rays to Lady Elliot Island every winter?
So the manta rays seem to be there's a couple things going on. The manta rays seem to be following a thermocline, so they like the water temperature to be about 24 degrees Celsius. And so during the summer months, they follow that cooler water down south. So they end up around places like North Stradbroke Island, around Byron Bay, South Solitary Islands. But then when the waters cool down in the wintertime, they come back up and they spend a lot more of their time around Lady Elliot. And the other thing that really sort of seems to encourage the animals to be there is, of course, food supply, right? So these thermal currents and these, particularly the upwellings, really determine where their prey is going to be. So they're following the temperature cues, but with that, they're also following that food resource as well. And Lady Elliot's really cool because it's only about 8 kilometers from the edge of the continental shelf, unlike a lot of the other Capricorn bunker group, for example, which are places like Heron. It's a bit further away. So it's really quite close to the edge of the continental shelf as far as the mantas are concerned, and that's where the upwellings are coming from. So they can go off the edge of the continental shelf, do these amazing dives at nighttime to meet the plankton as it's doing its nightly migration up towards the surface. Then their bodies chill down, so then they come back up to the surface, and during the daytime they come to Lady Elliot, get cleaned, because again they're using those filters within their gill rakers to filter out the food, and they need to get them regularly cleaned so they don't get clogged up, just like your Dyson's vacuum cleaner. And then they also are warming up when they come up to the surface as well. So food and temperature, those are the things that are really causing the animals to be where they are in space and time.
And so at places like Lady Elliot Island, manta rays are often found circling around particular coral outcrops known as cleaning stations. We've mentioned them a little bit, but for anyone out there who's not familiar, what is a cleaning station and what are the manta rays doing there?
So a cleaning station is an area where a cleaning wrasse called Labroides immediatus actually hangs out. And they're cool in their own right because there's usually a dominant male with a harem of females. And they're basically creating like kind of a spa treatment for not just the manta rays, but any of the fish that are in the reef. And what they do is they're picking off parasites, they're cleaning up wounds, they're removing any potential dead skin and things like that. And animals will come and seek them out to get this service because it's really important. It's one of the ways that the reef ecosystem itself can actually stay healthy. And we know that when you've got areas where there's no cleaning fish in that area, that your fish just generally just not are as healthy because they end up coming down with skin diseases and various things. So a cleaning station is usually, it can be anywhere from the size of a large room to the size of a 2-bedroom house. So they're quite large areas that the animals will basically patrol. And as I said, there'll be a dominant male with multiple females. But when the mantas show up, all ideas about territory completely gets thrown out of the window because all of the cleaning fish from around the area will all come and diverge on that manta ray because they're so big. There's so much access to parasites, to dead skin, that they all just come in and basically share this one large animal.
So it's an all-you-can-eat buffet.
It is literally an all-you-can-eat buffet. And the mantas, again, as I said, really important for them because they'll actually, the mantas will have their mouths wide open and they'll have their gills flared. And the cleaning fish are going in and out of the gill rakers. Again, as I said, picking off parasites, basically unclogging things if there's stuff stuck in there. They'll pick that out, as well as stuff around their skin as well. So, we've had mantas show up with a fresh shark bite, and the cleaner fish will go in there and start cleaning up the edges of it. And, if some of the skin is dead or rotten, they'll pick all that off as well. So really, really important. And we think that the mantas are so regularly visiting Lady Elliot because we have these amazing cleaning stations, which are quite large, with large numbers of fish. And there's other fish that will join in, like the moon wrasse will also join in cleaning as well, that they'll feed at night off of the continental shelf, and then they come up into the warmth, come to Lady Elliot Island, have a bit of a spruik up, get all nice and clean, warm up, and then get ready for their nighttime adventures down into the deep again. So it's one of the reasons why we think Lady Elliot is just so important.
Wow, so it's kind of like what brings humans to Lady Elliot. It's their R&R, it's their spa treatment, get away, relax.
We got a resident cleaner wrasse in the shark tank called Wayne, and I talk to customers about it every day. He has his little cleaning station there. But I remember way back when we filmed a resident cleaner wrasse out at Norman Reef. We filmed him for the entire day, and in one day he cleaned over 2,000 fish.
Yeah, they're really busy all of the time. And they're really cool. They've got that little dance that they do to call their clients in, so to speak, and then the clients will just basically go into a kind of stasis where they'll sit there with their mouths wide open and their gills flared, and the fish just dart in and out and pick out all the parasites. And normally, in that kind of scenario with a little fish and a big fish, the little fish would be lunch, right? But there's these cues that the cleaner fish give the larger fish to say, hey, don't eat me. I'm actually worth much more to you alive than I am as a very tiny snack.
That would be my survival strategy if I was a tiny fish. I'd be like changing into my cleaning outfit.
Well, what I noticed with the cleaner wrasse was that when they approach the customer, they sort of approach the back end first and start vibrating and do this little dance at the back, and that tells the big fish, I'm back here, don't eat me if you want to get cleaned.
Yeah, that little dance is really important, and not necessarily every interaction the cleaner wrasse is actually feeding on things. Because like you said, Brett, you filmed one basically providing services to 2,000 fish. If it was picking off even just one parasite per fish, that's 2,000 parasites that it's trying to eat in a day. So they found that even just the tactile of the smaller cleaning fish actually just rubbing up against the other fish will bring them back without them bursting because they've just eaten way too much. So there's even this almost like a little massage thing that goes on as well. So even if they're full and they can't eat anymore, they'll actually still undergo this tactile process.
It's the full service,
You've had
isn't
enough.
it? Massage, cleaning, day spa, foot massage, flipper massage. I mean, they're pretty awesome.
I agree.
Another interesting behaviour that I observed when I was snorkeling with the manta-rays at Lady Elliot Island was the romance train, which is when the female is being pursued by multiple suitors. Can you tell us a bit about that?
Yeah, so that's the courtship trains. And that is really interesting behavior. So what ends up happening is that there's one female at the front, and then there can be up to 8 males following along behind her.
Gee, it's popular life being a female manta ray. They don't have to go on Finder.
Exactly. She definitely doesn't need to go on Tinder. She just shows up and all of a sudden she's got a whole bunch of guys looking for her. And it's really cool because she then puts them through their paces. So she will swim, and it's expected that the train of males are going to follow her the whole time. And so she'll do things like loop-de-loops and various other things that will occasionally smash up the train that's behind her. And in the meantime, what's happening with the males, and this is really the most aggressive that these animals get, is that the males are basically following along behind her, and it's like a warplane formation where the males are basically trying to get in front of each other to be in pole position. And pole position is the one right behind the female.
I saw her first. No, I saw her first.
There's this big argument between all the fellas. No, I bought her a drink first. She's mine.
Yeah, exactly. But it's just this really great... So it's no punching. It's no headbutting. It's this really slow, graceful maneuvering, which sort of is showing their ability to swim in very precise manner. And one of the volunteers that we had with us, he was an ex-RAF navigator. And when he watched this behavior, he said, this is exactly the kind of stuff that we do when we're doing dogfighting, where we're trying to basically get in front of the other one to get in position to, be close to the target. So it's this really beautiful, gentle, yet they're still competing against each other, right? And one of the consequences of that is I kind of discovered this whole fighting to be in alpha position because at one stage we had sea-doos, which are those fan motorized things that you hold on to that can pull you through the water as a snorkeler, because when they're undergoing this behavior, they can cover kilometers. They just go one little swoosh of their fins and they're gone. So we ended up getting these sea-doos to follow along behind the courtship trains. And I made the mistake of getting between the primary male and the female, and he was not happy about that. And so he was basically trying to get me out of the way. And that's when I discovered, well, okay, so this is the thing. They were quite happy for me to join at any other position. I could join the train anywhere else, but I could not be between the female and the primary male, because that is what the whole thing is about, is being that male that's behind the female.
Take note, fellas. No violence is the answer to winning a female.
That's right.
Yeah, polite, gentlemanly, excuse me, that's actually my spot. I was at the front.
Yes.
Thank you.
Yeah. Well, and on that same topic, we were very fortunate to film for the BBC. And when we were filming for the BBC, we had a male and female show up at one of the cleaning stations, and we were filming them. And the male started this behavior I had never seen before. He was sort of hovering above the female, and he was using his cephalic lobe, so remember those pointy bits out the front of his face. And he was actually using them to stroke the back of the female, and I had never seen that before. And he was actually kind of curling his cephalic lobe down along her tail, like almost like
okay, so he's hands-on.
Yeah, he was quite hands-on. And it was just amazing. And so I had to, of course, we can't speak underwater, so I'm trying to call over the cinematographer to come and film this. I'm like, this is incredible. I've never seen this before. You must take imagery of this. And it was quite spectacular. So obviously these two had gone through this courtship train. It was down to the last of just the two of them. He was still trying to convince her that it was time to mate, and it was quite funny because she's the one that makes the decision. He was busy stroking her, and then every once in a while she'd sort of fly up into the water and go, "Get away from me!" And then she'd settle back down again, and then he'd start it up again. But yeah, it was quite spectacular to watch. Again, just really gentle, slow, graceful behavior. Even when they're undergoing this courtship behavior, which, as we know, not necessarily all courtship behavior for animals is gentle. The Lasmobranchs are quite notorious for not being gentle and biting one another. But yeah, with the mantas, that whole courtship behavior, and it can last days, the whole courtship train, until they get to the stage where there's just one male and one female. But then when they do undergo the actual reproduction, it's pretty quick. The male will hold on to the female's left fin, and then they basically go belly to belly, and he's still holding on to that. He'll insert his left clasper. It's always the left. Don't know why, just is. And the whole process lasts maybe 60 seconds. They flap around on the surface, and then they break apart, and then that's it. They don't see each other again. So they don't have mates for life or anything like that.
You mentioned about filming for the BBC, so maybe that's a good time to just casually mention your time filming with Sir David Attenborough.
Yes, a big name drop.
Yeah, that was the day that I felt like a real marine biologist, right? It was quite spectacular. I think one of the reasons that it was just such a privilege is that this is the very last documentary that Sir David did out in the field, because he had turned 90, and the BBC turned to him and said, okay, you're getting to that point where you're probably not going to be able to go out and do these sorts of things anymore. Where do you want to go? Of all your career, of all the various things that you've seen throughout your life, all the places that you've filmed, where do you want to go? And he chose to come to the Great Barrier Reef.
Wow.
And as I said, it's his last. He's still doing voiceovers now, but it was the last time they actually took him out into the field. And he had a submarine and all sorts of things. And it was very exciting and, of course, extremely special to be involved in all of that. And I still, to this day, one of the most exciting things I've ever seen is I got a script sent to me by the producer, and there's, Sir David speaking, and then I'm speaking, and then he's speaking. I'm like, oh, this is a bucket list. This is absolutely amazing. And, so he was with the manta, that little sequence that I told you about the male and female manta. The female, we ended up knowing who she was. She was Trilou Bibi, which is, I used to have a French PhD student, so it's one of the mantas that she had named. But the male didn't have a name. And so we asked the BBC and said, do you think Sir David would be willing for us to name a manta-ray after him? And we were going to call the manta-ray Sir David, and they said, oh, he'd be very honored. However, you can't call him Sir David, because to be called a sir means you have a knighthood, and you can only use that name if you have a knighthood. So our manta, we couldn't get to the Queen at that time. The Queen was still alive to get knighted, so we ended up having to sit with Attenborough. So we have a manta-ray named Attenborough. Swimming out there at the Great Barrier Reef and around Lady Elliot.
Well, I feel like it would have been great if the Queen could have come out to knight the manta-ray. Just, a couple of quick taps over the fins with a sword.
Get her down there in scuba gear with a tiara on.
Yeah.
Yes. That would actually be the thing I'd like to see the most. The Queen in scuba gear and a tiara. That'd be awesome.
Well, I think normally for many people it's very much an honour if you get to have a manta-ray named after you because you've photographed a new one. But in this case, I feel like the manta-ray is very honoured to be named after Sir David.
He might go straight to the front of that courting process.
Yeah.
Yeah, well, he might do. Well, he was already successful, as we could see. So there you go.
So you've given names to all the manta rays that you've logged. We talked about a couple. We talked about Taurus. We've talked about Attenborough. What are some of your other favourites, and do they have different personalities?
Yes. So I guess probably one of my other favorites is Inspector Clouseau. And Inspector Clouseau is a male that we know from Lady Elliot Island, and he is the only known pink manta ray in the world. He regularly shows up. He's not albino because he still has black markings on his belly. He still has a black back. His eyes are black as well. But where he should be white on his belly, he is bright fuchsia pink.
Wow.
We're not talking pastel pink. We're talking fuchsia pink. And the first time somebody sent the photos to me, I thought that their white balance was just off, because when you're diving, you often pump up the reds because red is the first thing that disappears when you go diving. And so I thought somebody had just had their settings from when they had been much deeper and took a picture of the manta near the surface, making it look like it was pink. But no, Inspector Clouseau is definitely pink. He is very healthy male. Every time we see him, he's busy courting some sort of female. And we had to try to figure out, why is he pink? Because
it's man salmon, if you please.
It's man salmon, exactly. Well, it's a bit of a shame he's not female, because I always thought he'd be a really great mascot for breast cancer, the pink days that everybody has, because he's very, very pink manta. So we had to try to figure out what might have been happening. So the first thing we thought, when we first saw him, maybe he just has a skin disease of some sort. Maybe he's unwell. But that pretty quickly went by the wayside, because we first saw him in 2015, and we still see him to this day. So it's a bit over 10 years since we first saw him. And we see him almost annually, and he's still bright pink. And he's healthy, and he's eating well, and he's got all the signs of reproducing and things. So it's not a health-based thing. And then we thought, maybe it just has to do with his blood vessels just being really close to the skin. Like sometimes, people have those really red cheeks and red noses that you can get, and that's caused by...
Are you saying he's an alcoholic?
Mm-hmm.
Well, we thought we better check. And so we were able to get a skin sample to have a look at that, because if he had a whole bunch of little tiny blood vessels up near the surface of his skin, then that would have caused that pink hue as well. And, we sectioned the sample, and no, that is not the case. So that led us to our last hypothesis.
Which he's been getting into the pink redskins and the pink jelly beans.
Yeah, he's been just doing too much of that. But we think what's ended up happening is he's had a mutation of his pigment cells. For some reason, Inspector Clouseau has had a mutation, and all of his white-presenting pigment cells are instead presenting pink. And he does have one little patch of white, but the rest of him is all pink. And he's probably my favorite, probably because he's our most famous. He's famous internationally. When he was found initially, he was all over social media. And as far as we're aware, and we work a lot with international researchers from around the world, it's the only known manta ray that has this color polymorphism. It's never been seen anywhere else in the world except for our one Inspector Clouseau. But he is busy mating. He's out there busy mating, so who knows? If it's some sort of recessive gene and he's found a female that has a similar recessive gene, maybe we'll have some other little pink babies in the future. Who knows?
That'll be adorable. Can't wait to find
a little baby pink manta ray being born. Okay, that's next level.
Adorable.
Yep.
Let's move on to threats. Are manta rays endangered or not? And are they a protected species?
Yeah, okay, so this is a sad part of the podcast. Yes, they are endangered. Both mobulid, so they've now changed the genera names, so mobulid elfredi and mobulid birostris, are actually considered to be vulnerable to extinction. The reason for that is because in some parts of the world, there's targeted fisheries for them. So fortunately here in Australia, that's not the case. Manta rays are actually protected in Australian waters completely. But in other places in the world, the animals are actually targeted, and it's for the Chinese medicine trade. They're a bit like rhinoceroses and other animals of that
Shark
ilk.
fins as well.
Shark fins and things like that. It's a small part of the body that has value, and the rest basically has no value. And with the manta rays, what they're targeting is the gill rakers. So they kill the animals, and the gill rakers are basically the lungs of the manta rays. So that's where they absorb oxygen through the water. And they remove them, they dry them, and then they turn them into a kind of soup, but it's a traditional Chinese medicine that is supposed to filter the blood. So it's often given to children who have chicken pox and things like that. So that's what the gill rakers are used for. They're worth a lot of money, a bit, again, like the shark fin trade. And not surprisingly, where you find shark fins is also where you find gill rakers as well. And again, just to give you more in-depth on the sadness of this story, the location in Mozambique where Andrea Marshall actually discovered the fact that we had two different species of manta rays, not just the giant ocean manta, which up until that point everybody thought there was just one species. It was a location which had both of them that would visit, and she was doing photo identification as well as doing genetics. But it was the photo identification that started to make her think, wait a minute, there's two kind of larger groupings of animals that I'm seeing here with quite different morphological features. Not hugely different until you compare them side by side. And it was because she had these two populations side by side, she was able to discover there was actually a brand new to science species of manta ray, which is now Mobula alfredi. It turns out that's the one we had in Australia as well, so we had been calling the one that we had here the wrong name. It wasn't the one we thought it was. But that population where she had made that discovery has now all but disappeared because of overfishing, to the point now where she's now moved her main study site to other locations. There's not enough manta rays around for her to be able to continue her studies in that region. And, of course, completely heartbreaking for her because she would go to the local fish markets and she would see the mantas there, belly up, and know exactly who that individual was because of the spot and dot pattern. So absolutely so heartbreaking. Yeah, and absolutely heartbreaking. And, again, just seems like something that doesn't need to be like that because, again, a very small part of the animal which has value, and these beautiful long-lived creatures that can live up to 80-plus years old are being sacrificed. And so hence they also don't bounce back quickly, which is what we've seen in Mozambique as well.
I think that highlights the value of diving and getting people out there to get to know these creatures, to sort of see them as individuals with different personalities. And if you can fall in love with these animals, then it inspires people to respect them instead of sort of just seeing them as a
commodity.
Yeah, just a commodity. But also some areas, once they introduce developing countries to tourism, then they're more likely to protect the species. So, for example, I've done various manta ray dives in Indonesia, and so I think the tourism visiting the manta rays is helping the local people to have a greater incentive to protect those animals. Do you think that's the case, Professor Townsend?
Yeah, 100%. And we have to be really cautious when we start talking about conservation in developing countries, right? Because often it can be the difference between feeding your family or not, right? So we really have to make sure that, well, first of all, you should be working directly with the local group. You shouldn't be helicoptering in and telling people what to do. But you have to be very cognizant of the fact that you can't take something away without giving something back, because people still need to survive. They still have to feed their families. So exactly what you were talking about, Tanya, is creating another industry like around tourism, which then can subsidize that wage. Instead of the fishing and shark finning and other things like that, you now find that the value of that animal is worth much more alive than it is otherwise. And we've written multiple papers on this, actually, in various places around the world, showing that a live manta ray is worth infinitely more than one single dead manta ray. So a single dead manta ray can get about $250 US on the market. However, that same manta ray alive through its lifetime can raise over $1 million in tourism revenue. So it's about providing those opportunities, and it's all good and well to say, yes, that's the case. If you stay alive, you'll get more money. But it's also providing those people with those opportunities to do that. So providing help for the fishermen to change their boats from commercial fishing to now being able to take tourists on board that vessel and make money in a different kind of way. So, yeah, it's again, one of those sort of philosophical questions. We need to be cautious when we're working in these other regions, particularly in developing countries, and work with the community there, because otherwise, as soon as you walk away, nothing's going to happen. They'll just go back to the same way that they had done previously. But also, we're very fortunate in Australia and other places in the world that we do actually have the luxury of conservation and saying, no, we are going to preserve that species. We are going to preserve that landscape because you know what? We're actually okay. All of our needs are now met. But if you're working in developing countries, you have to be working and coming up with very strategic ways to make sure that people are not going to be disadvantaged unfairly, because then what that happens is it causes people to become very angry, and then you can get basically a throwback where the animals then start to be actively targeted because people are annoyed that they perceive that the government cares more about the animals than they do actually about them. So, yeah, it's always something to be worked with great consideration and thoughtfulness.
Yeah, and as good neighbours and a wealthy country, Australia should be helping out in our neighbours. And speaking of that, Australia has an interest in, if we want to protect our manta-ray population, then we should definitely be providing that foreign aid to other countries like our neighbours, Indonesia, to help them to not be so poor that they have to rely on killing manta-ray. So, and so with your tagging and tracking of the East Coast population, do we know if they're going up into the Asian waters?
We suspect that probably the West Coast population, sat tags don't stay on these animals for very long. The maximum length of time we've had sat tag deployed on them is about 3 months because they pop off pretty quickly. The mantas will actively scrape them off, or big trevally fish will come and actually bite it off. So sat tags don't really last too long on these animals. So we haven't got sat tag tracks going across borders yet, but we've seen them fairly close. But we think that the West Coast population is probably heading up into the Indonesia, whereas the East Coast population is probably heading up to PNG waters instead. So we've got the mantas of Australia moving across multiple international boundaries, not just one single one.
Very good reason for us to be working with our neighbours in jointly protecting those mantas. What threat does climate change pose to manta rays?
Manta rays are kind of like our canary in the cage as far as climate change is concerned. And the reason for that is that as oceans warm, as the climate changes, plankton in particular is one of those groups of animals that are very easily and quickly impacted by those changes. So, if the water's too warm, the plankton gets shoved down deeper, or if it's too warm, it doesn't create upwelling, so then you don't have the diatoms blooming, which then means the zooplankton doesn't bloom. It changes currents, so it changes the strength and the direction of currents as time goes on. And so with manta rays, climate change is doing a couple of different things. It's messing with its food resource. It's messing with those areas that they go to regularly try to find food, because they'll be a bit like the story we were talking about, the Maldives, where there's a certain season, a certain time of the year when all the plankton ends up in that one location. When you start to mess around with the environment, those sorts of regular occurrences start to change, either in intensity or where it occurs. And of course, then that messes with the manta rays being able to find these really rich food sources that they would have historically been able to exploit. So food resources, and then the other thing is just movement as well, right? Because I was talking about how manta rays basically on the East Coast are following that 24 degrees Celsius water current. If it starts to warm up so you don't get 24 degrees anymore, they're going to just slowly move further and further down south, which means that they're now further away from their regular food sources. They're further away from places like their cleaning stations that they regularly go to, and they become basically displaced. So manta rays are just one example of animals that are, these are the kind of things that climate change is impacting their movement through space and time. It messes with reproduction patterns because often temperature is one of those cues, particularly for the whales. I mean, just bringing whales into the idea of this. Whales from the Antarctic, it's the cues of what the temperatures are that tells them it's now time to start our northerly migration. And so if they end up getting warmer sooner or at a different time period, it actually also messes up these reproductive migrations as well. So lots of things beyond just food, but that can actually impact these animals around climate change.
So many flow-on effects from climate change, and then if the manta rays are moving further south, then there's going to be clashes with the ecosystems down there.
Yeah.
It's definitely a problem. What do we need to do in our everyday lives to help protect the ocean and the manta rays?
Well, manta rays, like so many other animals, are, of course, impacted by things like marine debris, and another area of my study is the impact of marine debris on sea turtles, but mantas are also impacted by it. They can get entangled in stuff. They can get, microplastics they can end up actually physically eating. So, you know what? Just like everything, just reuse, reduce, recycle. Make sure that you're limiting your amount of single-use plastics. If you are using things, just make sure everything is disposed of correctly.
Yeah.
And, of course, climate change is a really big issue because manta rays are going to be our canary in the cage as far as climate change is concerned because they're feeding on plankton, which responds very quickly to climatic changes. So, again, that is a big, wicked problem, but it's, of course, one of those things we really do need to tackle head on.
Yeah, definitely. Having a more long-term approach to not just thinking about how we can make money right now, but how to leave a sustainable world for future generations. And I think that's actually perfect note to pretty much wrap up on. Is there anything else that you wanted to add, Professor Townsend?
No, thank you for having a chat. We've talked way longer than we were going to, but I really enjoyed it, and thank you for inviting me along.
Thank you so much for joining us.
This has been an amazing chat. We've just loved every minute of it. Thank you so much for all your incredible work that you're doing with those beautiful mantas and the turtles.
Thank you so much. Enjoy the rest of your day.
Bye-bye.
Bye.
Bye.